Hello, dear students. This is chapter number 2. This is a presentation and review at the same time. In this chapter, we are having measurements and calculations. It is very important to pay close attention to this chapter because from now on, you need to do all the calculation and all the measurements following the instruction that I will give you today. Well, here at the beginning, we are going to speak about scientific notation. Let's see. For example, if you have a big number like this one, a 9, a 3, and 6 zeros, and I want you to express this in scientific notation, all what you have to do is to move the dot. The dot is supposed to be here, then you move 1, 2, 3, 4, 5, 6, 7 spaces. And why 7 spaces? Because we always give a whole number at the beginning and then the dot. Then you write 9.3 times, and then you have to multiply by this big number. In other words, you have 7 zeros, then you say 9.3 times 10 to the 7. We don't write the zeros in this case because they are trailing zeros and they are not significant figures. Later, I will explain you what is a significant figure. But in the case that the number is too small, like in this case, for example, you have here 0.0671, then you move the dot 2 spaces, and now you have the 6, a whole number, the dot 6.71 times 10, and how many spaces you move the dot? 1, 2, then it is 2. As you are moving the dot to the right, the exponent will be negative. Look in the first case that you move the dot 1, 2 spaces to the left, then the exponent is positive. Remember, always we have a whole number and then the dot. This is what we call scientific notation, and we use the scientific notation in order to convert the numbers in small ones. Look at this. Here you have an example. You can do it, and you will see that the answer is C. Same thing here. You move the dot to the left 5 times, then it's 4.96 times negative 5. Well, it is important to know that we need to use units according with the scale that we are using, and we have two systems of units that are the English system that is used in United States only, and the metric system that has been transformed into the international system, or SI. In the international system, the units, the physical quantities are mass expressed in kilograms, length in meter, time in second, temperature in Kelvin, electric current in ampere and amount of substance in mole. Mole is very important in chemistry, and we are going to use it in other chapters. Well, we use prefixes in the international system. Mega is 10 to the 6th. Kilo is 10 to the 3rd. Deci is 10 to the -1. Centi, 10 to the -2. Milli, 10 to the -3. Micro, 10 to the -6. And nano, 10 to the -9. For example, 1 kilometer has 1,000 meters. 1 meter and 1 decimeter is 10 to -1 meter. 1 centimeter is 10 to -2 meters. 1 milliliter is 10 to -3 meters, and 1 micrometer is 10 to the -6. Volume is a measure of the amount in 3D space occupied by a substance. In the international system, the unit for volume is a cube meter. And we usually use a cube centimeter, and we use this equivalence. 1 cube centimeter is 1 milliliter, or 1 cube decimeter is 1 liter. The mass is expressed in kilograms, as I told you before. The equivalence into the English system is that 1 kilogram is 2.2046 pounds, or in other words, 1 pound is equal to 453.59 grams. The other unit that we are going to use is the second, the hour, and the minute in the time measurements, and also we are going to use the mole that will be explained some chapters later. Here you have a question. You can stop the video, you try to answer. The answer is already given here. Okay, what is the uncertainty in a measurement? For example, if you use this ruler and you're going to measure this stick, you can be sure that the stick is 3 centimeters, but it's something else. Then in this case, you have to estimate a unit between 3 and 4, and then you decide maybe is 0.5. Then the answer in this case will be 3.5. You are certain about the 3, but the 5 is estimated. Then you always estimate the last digit. Here you have an example of measurement. In this case, this nail for sure is 2 centimeters. But something else, you can see that is 2.5. Sorry, 2.5678, and you're sure that it is 2.8 centimeters. Oh, but it's something else. Then you estimate and you say, well, the last digit, the one that I will estimate is 5. It depends on the person that is doing the estimation. Someone will say 5, someone will say 4, someone will say 3. But we are sure that it is 2.8 centimeters. This is what you are certain. But 5 is always estimated. Remember that we always estimate the last digit. Well, according with the measurements, you can express what are significant figures. For example, in a number that have non-zeros, you can say that all the numbers are significant. In this case, you have 1, 2, 3, 4 significant figures. But if you have zeros to the left, you say that these zeros are not significant. Then this number has only 2 significant figures. If you have zeros in between two numbers, you say that this zero is significant. So this number has 4 significant figures. In this case, that you have a dot, you say that these zeros are significant. So here you have 4 significant figures. But in this number, you don't have a dot. So you consider that the 0 is not significant, and this number has only 2 significant figures. When you have an equivalence like this, 1 inch is equal to 2.54 centimeters, you say that this is an exact number. Also, when you are counting things, for example, when you say that 9 pencils, then you say that this is an exact number. And an exact number has unlimited number of significant figures. For example, in this case that you converted 3.00 into scientific notation, you say that these zeros are significant. But what happened? In this number, in 300, you don't have a dot. Then these zeros are not considered significant. If you convert this into scientific notation, the way you have to express it is 3 times 10 to the second. Then 300 is 3 times 10 to the second. And this number has only 1 significant figures, because this part of the exponential part in scientific notation is not considered a significant figure. Well, for example, if the digit when you are rounding up or rounding off, for example, if the first number that you are going to skip is lower than 5, you round off. Then you consider that 5.6 is, 5.64 is 5.6. If in this case, the first digit that you are going to skip is higher than 5, then you round up and your answer will be 5.7. And this number has 2 significant figures, as in this case. Let's continue. Let's continue. Here, you have the rules for rounding off. You can stop the video and read it. I think that this is not new for you. For example, when you are multiplying or dividing, you say, well, this number has 4 significant figures, but this has only 2. Then you say, well, the number with least significant figures in a multiplication or division will give me the number of significant figures to be reported. Then you multiply, you will get in the calculator this number, but your answer will have only 2 significant figures, because the rule in multiplication and division is to report the number of significant figures in the factor with least significant figures. When you are doing, for example, when you are doing a conversion, for example, a golf ball 6.8 feet across a green. How many inches that this represent? Then you have to convert 6.8 feet into inches. You know, let me raise here in order to explain you step by step what to do. Well, you know that 6.8 feet is the given number. And you know that in 1 feet, you have 12 inches. You use this as a conversion factor, and you always write down the unit of the given number and add the number of the wanted or the needed number in such a way that you can cancel units and the final unit will be the one that you are asked. Then you multiply 6.8 times 12 and you will get the following answer. You multiply, you cancel feet with feet, and then you get the answer 28. And why you give only 2 significant figures? Because the given number has 2 significant figures. So the answer must have also 2 significant figures. Okay? Here you have another example. You can stop the video and study what you are doing. In this case, the conversion is in 2 steps. But look at this. The answer has the 3 significant figures because the given number has 3 significant figures. Don't forget about this. If not, you're going to lose points in the test. In this case, you say, well, I have to go from New York to Los Angeles. And you know that the distance is this one. But you want to know how much money you will need to pay for the gas. In this case, you say, well, I have to convert miles into gallon. And later, gallon, according with the price, in this at this moment exactly 3.25 or something else the gallon of gas, then you cancel miles with miles, gallon with gallon, and you get the amount of money that you will need to go from New York to Los Angeles. You can stop the video and see what is going on. Well, here we have 3 units for temperature. Fahrenheit, that is the one that we use in United States. Celsius, that is used all over the world, and Kelvin, that is the international, in the international system, is the unit that is used. Well, you need to know what are the conversions from one to another. Look at this. Knowing that the boiling point of water is this in Fahrenheit, in Celsius, and in Kelvin, and the freezing point is this one, you can do, okay, you can get the following conversion equations. For example, in order to go to Kelvin to get Kelvin from centigrades, you have to sum to 73. For example, 20 Celsius degree to Kelvin is 293. If you want to go from Kelvin to Celsius, you have to subtract 273. If you want to go from Fahrenheit to Celsius, you have to use this equation, or the opposite. If you want to go from Celsius to Fahrenheit, you have to use this equation. Here you have a question. You can stop the video and you can see the answer. Okay, let's continue. Let's continue. Here we have some other conversions that you can use. You can stop the video. This is the presentation that I sent you, and I want to stop into here. Density. Density is the relationship between mass and volume. Density is characteristic of every type of substance. For example, if you want to measure the volume or the density of a solid body, what you have to do is to introduce the solid body into an amount of water. In this case, is this one. And when you introduce the solid body, you can see that the volume increases. Then you say from here to here is the volume of the object. If you previously measured the mass in, for example, grams, and you get the difference of volume in cube centimeter, then you can estimate the density, saying that is the mass in grams divided by the volume in cube centimeter. What is equivalent to grams per milliliter, since 1 cube centimeter is equal to 1 milliliter. Well, not equal, but equivalent. Let's continue. Here we have an example of how we can do a calculation of density. If you know the mass and you know the volume, you can get the density of a certain mineral. You can stop the video and see the operations. Okay, here you have Another example, stop the video and watch it. Try to do in your notebook at home. Here you have another example. Stop the video, try to do it. And the same thing here. Well, I hope that now you have a better idea about the different things that you are going to study during this chapter 2. Thank you. If you have any question, don't hesitate. Tell me, Professor, I need your help. And then we are going to have a meeting in Zoom at certain time.